Okay, what does one-to-one mean? Well, it's a property that some functions have. Many functions do, okay? It says that for any y, is exactly one value of x. Okay? And we should maybe say for any y in the range, there's exactly one value of x in the domain. Okay? Now, what does that mean? Well, if your graph looks like this, a parabola, give me a value, well, a y in the domain has to be somewhere above the lowest y value, so here's a y value. Well, here's an x that goes with this y value, and here's an x that goes with the y value, right? This is not one-to-one, right? And that would be for any parabola, unless you restrict the domain to one side or the other, say, of the vertex. Okay? Now what's that look like? A bunny rabbit, right?
Oh, yeah.
If you see a bunny rabbit in that, you got a better imagination than I do. Then you might well. Okay? What kind of function does that look like? Now you really need to know.
It's one of our functions.
You really, need to know what the graphs of the basic functions look like and what their names are, right? Exponential, squaring, cubing, reciprocal square, reciprocal, cube. Okay? If I didn't say that already, square root, all that. Okay? Now, is this function one to, okay, you should be able to identify that immediately from the shape. There's no other graph that has that shape, okay? None of the basic graphs have that shape. Okay, there's the exponential function. You don't need to know that. Is it one-to-one? Well, if y is here, how many x's are there? There's just one, right? If y is here, there's exactly one x. If y is here, there's exactly one x, right? It becomes pretty clear that there's no way you can find an x or a y value that has two x values associated with it, right? Or a value y that corresponds to two different x values, okay? Every y in the range
You'll do that better.
corresponds to exactly one x. And of course, if it corresponds to some x, that x is in the domain, so it's a little redundant to say in the domain, but for reference we say it anyway. Okay?
Mm-hmm.
Make sense?
Yeah.
Now what's the test for one-to-one then? The horizontal line test, okay? Which is something maybe you want to look at in your text if you didn't pick up on it, okay? But simply, the horizontal line test says there's only one point at which the graph meets any horizontal line, right? And that's easily seen to be equivalent to this idea of one-to-one if it's defined like this, okay?